A 90-degree conduit nipple under 24 inches in length is indeed considered a short nipple and is exempt from the 60% fill rule as per the National Electrical Code. This exemption is explicitly stated in NEC Article 358.30d. This section addresses situations where the conduit nipple's length between boxes, cabinets, or equipment is less than 24 inches. In such cases, the number of conductors permitted within the nipple is not limited by the standard fill provisions outlined in section 358.30. This exception exists primarily because short conduit nipples, due to their limited length, have a reduced impact on heat dissipation and wire pulling difficulty compared to longer conduit runs. The code recognizes that the factors necessitating the 60% fill rule are less critical in these short nipple applications. The 60% fill rule, in general, is implemented to prevent overheating of conductors, facilitate easy wire pulling, and ensure the long-term integrity of the wiring system. Overfilling a conduit can lead to several problems. Firstly, it can restrict the ability of the conductors to dissipate heat effectively. Electrical current flowing through conductors generates heat due to the resistance of the wire. If the heat cannot escape, the temperature of the insulation surrounding the conductors can rise. Elevated temperatures can degrade the insulation, causing it to become brittle and crack over time, potentially leading to short circuits, ground faults, and even fires. Secondly, overfilling a conduit makes it significantly more difficult to pull wires through. The increased friction between the conductors and the conduit walls requires more force to pull the wires, increasing the risk of damaging the insulation. Damaged insulation can compromise the safety and reliability of the electrical system. Thirdly, the 60% fill rule helps to ensure that there is enough space within the conduit for future modifications or additions to the wiring system. If the conduit is already full, it may be necessary to install a new conduit run to accommodate additional conductors, which can be costly and time-consuming. The exception for short nipples acknowledges that the risks associated with overfilling are minimized in these specific scenarios. The reduced length means less heat buildup and easier wire pulling. However, it is important to note that other relevant factors, such as conductor ampacity and voltage drop, must still be considered when designing and installing electrical systems. Even though the 60% fill rule does not apply to short nipples, the conductors must still be appropriately sized for the intended load, and the voltage drop must be within acceptable limits to ensure proper equipment operation. To fully understand the implications of NEC Article 358.30d, it's helpful to review the general fill rules for conduit as well. Firstly, the standard fill rule dictates that the total cross-sectional area of the conductors within a conduit cannot exceed 40% of the conduit's internal area for 3 or more conductors. This limit is intended to provide adequate space for heat dissipation and wire pulling. Secondly, for a single conductor in a conduit, the maximum fill is 53%. Thirdly, for 2 conductors, it's 31%. These percentages are based on the internal area of the conduit. To determine the allowable number of conductors in a conduit, you must first calculate the cross-sectional area of each conductor using tables provided in the NEC. These tables list the area of different conductor sizes and insulation types. Then, you sum the areas of all the conductors to be installed in the conduit. Finally, you compare the total conductor area to the allowable fill area of the conduit. The allowable fill area is calculated by multiplying the conduit's internal area by the appropriate fill percentage. If the total conductor area exceeds the allowable fill area, you must either increase the conduit size or reduce the number of conductors. The exception for short nipples is just that, an exception. It's crucial to understand the general fill rules and apply them correctly in all other situations. It is also essential to consult the latest edition of the NEC and any applicable local codes to ensure compliance. Local codes may have additional requirements or restrictions that go beyond the NEC. The NEC is updated every 3 years, and it's important to stay current with the latest changes. The NEC contains a wealth of information on electrical safety and installation practices. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a design manual, but it provides the minimum requirements for a safe and reliable electrical system. It's the responsibility of qualified electrical professionals to design and install electrical systems that meet or exceed the NEC requirement. When working with conduit nipples, it's important to select the appropriate type and size for the application. Firstly, rigid metal conduit (RMC) is a heavy-walled threaded conduit suitable for use in harsh environments and for providing physical protection to conductors. Secondly, intermediate metal conduit (IMC) is a thinner-walled threaded conduit that offers similar protection to RMC but is lighter in weight. Thirdly, electrical metallic tubing (EMT) is a thin-walled unthreaded conduit commonly used for indoor applications. Fourthly, flexible metal conduit (FMC) is a flexible conduit that allows for bends and offsets. The choice of conduit type will depend on the specific application and the environmental conditions. The size of the conduit nipple must be sufficient to accommodate the conductors and any necessary fittings. It's also important to consider the bending radius of the conduit, especially when using FMC. Sharp bends can damage the conductors and make it difficult to pull wires. When installing conduit nipples, it's important to follow proper installation practices. Firstly, all connections must be tight and secure. Secondly, conduit must be properly supported to prevent sagging or damage. Thirdly, any exposed threads must be protected from corrosion. It's also important to ensure that the conduit is properly grounded to provide a safe path for fault current. Grounding helps to prevent electrical shock and minimize the risk of fire. In summary, while NEC Article 358.30d provides an exception to the 60% fill rule for short conduit nipples under 24 inches, it's essential to understand the reasoning behind the exception and the general fill rules. Always prioritize safety and compliance with the NEC and any applicable local codes. Remember that the exception does not eliminate the need to consider conductor ampacity, voltage drop, and other relevant factors. A well-designed and properly installed electrical system is critical for the safety and reliability of any building or facility. Furthermore, let's delve deeper into some related considerations when dealing with conduit fill and the NEC. Firstly, understanding conductor types and their insulation ratings is paramount. Different types of conductors have different insulation ratings, which affect their allowable ampacity and suitability for specific environments. For example, conductors with THHN or THWN insulation are commonly used in dry and wet locations, respectively, and have a high temperature rating compared to conductors with older insulation types. The NEC provides tables that list the ampacity of different conductor sizes and insulation types based on the ambient temperature and the number of conductors in a raceway or cable. These tables are crucial for selecting the appropriate conductor size for a given load. Secondly, consider derating factors. The NEC requires that conductor ampacity be derated under certain conditions, such as when multiple conductors are bundled together in a raceway or cable, or when the ambient temperature exceeds a certain limit. Derating factors are applied to the ampacity values listed in NEC tables to account for the increased heat buildup caused by these conditions. It's important to carefully consider derating factors when designing electrical systems to ensure that the conductors are adequately sized to carry the intended load without overheating. Thirdly, be aware of conduit bodies and pull boxes. Conduit bodies and pull boxes are used to provide access to conductors within a conduit system for pulling, splicing, or making connections. The NEC specifies the minimum size requirements for conduit bodies and pull boxes based on the size of the conduit and the number of conductors. These requirements are intended to ensure that there is enough space for easy access to the conductors and to prevent damage to the insulation during pulling or splicing. Fourthly, remember grounding and bonding requirements. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip over current protective devices and prevent electrical shock. Bonding ensures that all metal parts of the electrical system are electrically connected, which minimizes the risk of voltage differences and electrical shock. The NEC has specific requirements for grounding and bonding, including the size and type of grounding conductors, the methods of bonding metal raceways and enclosures, and the grounding of equipment. In addition to these considerations, it's also important to be aware of the following. Firstly, arc fault circuit interrupters of size are required in many residential circuits to protect against arc faults, which are a common cause of electrical fires. Secondly, ground fault circuit interrupters, GFCIs, are required in wet locations such as bathrooms and kitchens to protect against ground faults, which can cause electrical shock. Thirdly, surge protective devices, SPDs, are used to protect electrical equipment from voltage surges caused by lightning or other events. Fourthly, energy efficiency is an increasingly important consideration in electrical design. The NEC contains provisions for energy-efficient lighting, motor controls, and other equipment. Always refer to the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Electrical codes are constantly evolving to address new technologies and safety concerns. Continuing education is essential for electrical professionals to stay current with the latest code changes and best practices. By understanding the NEC requirements for conduit fill, conductor opacity, grounding, and other aspects of electrical design, electrical professionals can ensure the safety and reliability of electrical systems. Remember that the NEC is a minimum standard, and it's always best to exceed the code requirements when possible to provide an extra margin of safety. Moreover, documentation is key. Maintaining accurate documentation of electrical installations, including conduit layouts, conductor sizes, and grounding connections, is crucial for future maintenance and troubleshooting. Accurate documentation can save time and money when problems arise and can help to prevent electrical hazards. Also, safety first is a motto to live by. Electrical work can be dangerous, and it's important to take all necessary safety precautions to prevent injury or death. Always de-energize circuits before working on them, wear appropriate personal protective equipment, and follow safe work practices. Furthermore, consider future expansion. When designing electrical systems, it's wise to consider future expansion needs. Providing extra capacity in conduits and panels can make it easier to add new circuits or equipment in the future without having to replace existing infrastructure. This can save time and money in the long run. In addition, remember coordination with other trades. Electrical work often involves coordination with other trades such as plumbers, HVAC technicians, and carpenters. Effective communication and coordination can help to prevent conflicts and ensure that the electrical system is properly integrated with other building systems. Don't forget load calculations. Performing accurate load calculations is essential for determining the appropriate size of service entrance equipment, feeders, and branch circuits. Load calculations take into account the anticipated electrical demand of all connected loads, including lighting, appliances, and equipment. The NEC provides methods for calculating loads based on the type of occupancy and the connected loads. And lastly, professional guidance is useful. When in doubt, consult with a qualified electrical engineer or inspector. Electrical design and installation can be complex, and it's always best to seek professional guidance when you're unsure about something. A qualified professional can help you to ensure that your electrical system is safe, reliable, and compliant with all applicable codes and standards. By keeping these additional considerations in mind, electrical professionals can enhance the quality and safety of their work and provide added value to their clients. The world of electrical systems is constantly evolving, and a commitment to continuous learning and improvement is essential for success in this field.